One of the most powerful skills you can learn today to talk with data and databases that are holding all that data is SQL. It lets you find exactly what you need from the huge pile of data and get clear answers. Companies are producing huge amount of data, and in order to manage all that data, no SQL or big data tools are used such as Hadoop or Cassandra. So why are we focusing on SQL? Well, SQL is like a stepping stone to understanding all these frameworks we just talked about. If you're preparing for a data-related role, you probably already know SQL is the core skill every data analyst, data engineer, business analyst, or even a software developer needs. Data is everywhere, from Netflix's recommendations, finding your favorite playlist on Spotify, tracking your order on Amazon, or browsing trending videos on YouTube. SQL is powering every decision, whether it's finance, marketing, or healthcare. Everyone needs data-driven decisions, and SQL is the language that makes it happen. And SQL isn't just simple commands like select and where. In this video, we will explore all the exciting stuff like subqueries, joins, aggregate functions, moving averages, and ranking functions. And trust me, by the end, SQL won't just be a language you know, it'll be a skill you master. With the queries covered in this video, you will definitely be able to crack whichever interview you go for, because SQL is a generalized tool being used by software engineers to connect API or data engineers for creating ETL pipelines. We've bifurcated the 15 SQL queries commonly asked in interviews into 5 easy queries, 5 queries focusing solely on joins, and the rest 5 deal with the important functions of SQL. So make sure to stick with us till the end and do subscribe to the Intellipaat's YouTube channel. So as you can see on my screen, I'll be using the MySQL Workbench tool to perform all my queries. And I have already created a database, that is, I have already performed the queries to create the table and insert the values in the table so that we do not waste any time in implementing those queries, right? So I have a table sales over here, and this is my data. I have my sale ID, I have my sale date, and I have an amount column, right? So let us see how our database looks like. So as you can see over here, this is my database, and I have my sale ID, sale date, and amount columns, right? So let's move on to our first question, which is write a query to find the total sales amount for each month of the year. All right. So in order to do that, first we need to understand the question, right? So the question is asking us to find the total sales amount. So intuitively, you should know that you will be using the sum function somewhere or the other in the query. And then we need for each month of the year, right? So somewhere we'll be using the month function as well. So let's go ahead and perform the query. But before you see the solution, do try to implement the solution by yourself. Alright, so whenever we write these reserved keywords, they should preferably be in capital letters. Although SQL is case insensitive, but it is usually preferred to, it makes the query look neater, right? So we select the month from the sale date. Now we do not need the entire sale date. We are only looking for the month of the year 2023. So we are going to give the condition 2023 later on, right? So let's call this month, and we also need the sum of our sales. So we're going to say sum of our amount. We'll call it total sales. So I'm giving alias names for each of my columns so that my database looks neater, right? And we are taking all these columns from table sales. Now comes my where clause, where my year of my sale date is equal to, you guys must have guessed it, 2023, right? And now we need it for each month. So we also need to group our result by month of sale date, and we should also order it to make our query look neater, right? We'll order by month because we have given an alias name month for this particular column, so we can just order it by month. So let's go ahead and run it. So as you can see over here, for month 1, I have 500.75 as my total sale. For month 10, I have 200.50, and for month 12, I have 150. So as you can see in the database, wherever my year is 2024, the month or that particular sale is not included, right? So this is how a basic query in SQL looks like. Now we'll be moving on to our second question, and this is the particular database or the tables created for the second question. One is customer and the second one is orders. So my customer column has customer ID, customer name and the city. So these are the details of the customers. And then I have my order table, which contains the order ID, the customer ID, the order date and the order amount, right? So now my question is to find the names of customers who have placed an order after January 1, 2023. Again, this is a very basic question and it is going to have a very simple query if you understand the logic, right? So in order to understand the logic more clearly, let me just show you the tables and let me also give you a basic introduction to the concepts of joins, right? So now I have my customers table over here and my orders table over here. So whenever we have two separate tables and we want to get the answers from both the tables, we will not do it separately. Rather, we will perform something known as joins, where we join the two tables into one common table and then perform a query, right? So now over here, as you can see, I have customer ID and customer ID over here as my common column, right? So once I find the column which is common in both the tables, I can easily perform the join based on that column. So this is an example of that particular instance. I have taken my customer ID as a common column, and as you can see, I have 1, 2, 4, 3, 5, right? So my customer 1 is Alice, customer 2 is Bob, customer 4 is Robin, and customer 3 is Charlie, as you can see. So this is how the tables get joined, and it gets very easy to perform the queries later on, right? So now what we're going to do is we are going to perform the joins first. So we're going to select. Now we need to find the names of the customers. So now we're only going to select the customer name, that is C dot customer name. From my table customers, and I'll give an alias name for my customers table as C, so that I do not get confused whenever I'm accessing a customer ID column, which is both common in the customers and the orders table, right? So once I give the alias name, I can simply access the columns using the dot operation over here. So I'm going to select the customer name from my customers table, and I am going to join with my orders table. I'll call it O, and I'm going to join it on O dot customer ID equal to C dot customer ID, right? Now my second condition is who have placed an order after January 1, 2023. So I'm simply going to give a where condition over here, where my O dot order date is greater than 2023 01 01, right? So let's run it, and you can see I have my customers who have placed an order after January 1, 2023. Let's cross check with our tables. So let's check the order date over here. So this is January 1, 2023. So this is the year 2024, this is the year 2023, this is the year 2022. So this should not be included. This is the year 2024. So again, this order was placed on January 1, 2023. But our question says we need to find the orders placed after January 1, 2023. So again, Alice Smith will not be included. We will have Bob Johnson who placed the order in 2024. And then we'll have Robin Smith who placed the order somewhere in October in 2023. Charlie Davis placed the order in 2022, so we cannot include him. And then Tom placed his order in 2024. So again, he's a part of our answer. Right, so I hope this is clear. So you guys must have noticed through this second question, we covered two major concepts, that is join and condition, right? Whenever we want to apply these two concepts in the same query, this is how our syntax is going to look like. So moving on to the third question, we have our employees table, which contains columns employee ID, department ID, and the salary. right? So our question is, we need to find the second highest salary for department 101. Now, if we were to find the highest salary, we would simply use the function max. Now, but here we need to find the second highest salary. So again, this becomes a challenge, but again, it comes in easy questions because this is a very commonly asked interview question. So in order to solve this particular question, we will be using something known as subqueries. And do not worry, it is not that difficult. Once you get a hang of it, it will seem really easy. All you need to do is follow the right syntax and the right logic, right? So let's get started. So we will select, now what do we need to find? The second highest salary for department 101. So we will only select salary, right? So let's target maximum salary as second highest salary. This is my alias name again. I'll be getting this from my employees table. Now this is only the first step. Now here I'm only getting the highest salary, but I need the second highest salary. Now if I were to run this particular query, I would get 7500, which is over here, as you can see in this particular database, the highest salary, right? But this is not what our question was about. So we need to give another condition that where my salary is less than, now comes my subquery. Now here I am going to fetch my highest salary using my max function again. So I need the maximum salary, but that maximum salary should be less than my highest salary. So this max salary is going to be my second highest salary, right? So I'm going to fetch my maximum salary from employees, right? And now my second condition is it should be for department 101. So now this maximum salary should be from department, let me just check the column name, otherwise I will get an error. So department ID, where my department ID is equal to 101, right? So this particular subquery is going to return the maximum salary for the department ID 101. But I need the second highest salary for the department 101. So my logic basically over here is to give another where, okay, I have already given one where condition. So in order to give two where conditions, we either use and or, right? But over here, both my conditions are necessary. So I'm going to use and I will give my second condition as same as this one. So let's run it. So now I have 5100. Now let's cross check this. So my department ID is 101, 101, 101. So it is 3 times, right? So I think the highest over here is 55000, and then we have 48, and then we have 51000. So as you can see, my second highest salary for the department 101 is 51000, which is our answer over here. So that means our logic is correct, and whatever syntax we have used, that is also correct because we did not get any error. So basically in MySQL Workbench, you get your action output over here. If your query runs successfully, you get a green tick, or if your query has some sort of error, you get a red cross over here, right? So I hope this question was very clear because this is a very commonly asked question. So moving on to our next question, we have our products table, we have our sales table, and in the products table, we have a product ID, product name, and the price. Clear? Then we have a sales table. It has a sales ID, product ID, and a quantity. Now you can see over here, we have product ID as a common column, right? You can see over here, product ID in sales and product ID in products. Now our question is to find the names of all the products that have never been sold. This is again a subquery based question. So now this should be very easy to implement because you guys have already got the logic. So I would suggest you pause the video and implement the solution yourselves and then come back and watch the solution here. So now this question can be performed in 2 ways. Either you can perform a join operation and then through the entire table you find whichever products have not been sold, or you can use the subquery method. So we will go ahead and look at the subquery method. So as you can see over here, I have my product IDs 1, 2, 3, 4 and 5. And over here, I have my product IDs as 1, 2, 1, 4 and 1. So as you can see, not all my product IDs have been included here. So it is pretty evident that there are some products that have not made a sale yet. So that is exactly what our fourth question is about, right? So what we need to do is, we need to find the names of all the products. So we will simply go ahead and select the product name from products, right? And simply give our where condition where our product ID is not in. So this question uses the not in operator. So not in is basically the opposite of in. So not in is pretty intuitive to understand. It is basically saying that the product ID should not be in our condition that we're going to specify after the in keyword, right? So it should not be in. And now we're going to select our distinct. Distinct is basically all the different product IDs that are available. Now where we're going to select it from? We're going to select it from our sales table. Select distinct product ID from sales, right? So now whichever product ID is not in our sales table, we are just going to return that. Simple enough, right? So let's go ahead and run it. Okay, there's some error. Okay, so it is just not in, not is not in, right? So that was the error in my query, and I'm sorry about that. So once we fixed it, all right, so we have a tablet and smartwatch. Let's go ahead and map their product IDs. So tablet has a product ID 3 and smartwatch has a product ID 4. 3 and 5 should not be included in our sales table, and as you can see, they are nowhere there. So this is how we know we've implemented the right logic. So every time you implement a query and you run it, you should always cross-check your output with the logic that you've implemented and the answer you find from the tables manually. So moving on with our fifth question, we have our table order, which basically contains the order ID, the customer ID and the order amount. Now our question here is to find the IDs of the customers whose total order amount exceeds $1,000 or any currency per se. So mainly over here we'll be using group by and having, right? So since we need the total order amount, you can intuitively think that we'll be using a sort of aggregate function which will be sum over here, and we will also be using a condition where we'll be saying that our sum amount should be greater than $1,000. Now we need to find the IDs of the customers. So now for every individual customer, we need to find the total order amount. So in order to do that, we will go ahead and implement our select. We need the customer ID and we need the sum of the order amount. Sorry, just okay, order amount. And we'll give an alias name as total order amount. All right. Now we're selecting this from my table order, and since we need the IDs of all the customers separately, we are going to group our query by the customer ID. Now we need to give the condition that the total order amount or the sum of the order amount for each customer ID individually should be greater than 1,000. Alright, let's run it. Right, so as you can see, this is our output over here. So we have two customers respectively with 101 and 103 customer IDs having the total order amount as 1100 and 1770. So as you can see, we have implemented the right logic and we did get our answer as well. So now let's move on to our sixth question. So for our sixth question, we have our table products and we have our table stores. And we have a third table over here, which is sales. So unlike our previous questions, in this question, we'll be dealing with three tables, right? So we will also learn how to join three tables together and get the queries respectively. So in our products table, we have a product ID, we have a product name and a category ID. Then in our stores table, we have a store ID, a store name and a city where the store is located. Then lastly, we have our sales table, which has a sale ID, product ID, store ID, quantity and the sale data. Right. So now our question is basically to find or to get the total quantity sold for each product in the laptop and table category from stores located in Los Angeles during the year 2023. So now in order to solve this particular question, let's break it down into simpler terms. So first let's look at the main terms over here, which is total quantity sold for each product. Right, so from these two terms, we know that we need to find the aggregate or the sum of the quantity column over here, and we also need to group by the product ID, right, because we need it for each product. Then we also need a condition where we segregate the laptop and tablet category. Then we need another condition specifying that these particular categories should have been sold only from the stores located in Los Angeles. Then our third condition is going to be the year 2023. So once that is clear, let us go ahead and understand this in a little more detail. Alright. So as you can see over here, we have a products table having product ID, product name and category ID. Now you can see over here product ID is a common column in products and sales over here. Store ID is a common column in stores and sales table. Right, so over here you can see sales table is our one table connecting these two other tables, right? Now in order to perform a join between these three tables, we're going to have our sales table as the common table between these two. So the order does not matter, but we will have to first either join the table sales and products or sales and stores, and then we can join the third table with these two tables, right, or the first two tables. So after performing a join on these two particular common columns, this is what our table is going to look like. So we have our sale ID, product ID, basically all the data from the above three tables, right? So now that we have understood the basic join logic for the three tables, now let's go ahead and implement the query for the particular question. So we will not complicate things, rather we will just follow the order of the question given to us. So we need the product name first, product name, that is from table products, so we'll call it p.product name. Then we need the sum of our quantity is from sales, so we'll call it s.quantity. Alright, and we'll give it an alias name, total quantity sold. Alright, now we are getting this from table products, giving an alias name P. Now we'll perform a join with our table sales, we'll call it S, and we are going to join our tables on s.product ID equal to p.product ID, right? So now we have connected a sales table and a products table. Now the next thing we need to do is connect a stores table as well, right? So moving ahead, we will perform a join on stores, I'll call it ST, and I'm going to join it on store ID, right? So s dot store ID equal to st dot store ID. So our joins are complete over here. We have joined the three tables and we have mentioned the total quantity sold for each product. Now to find each product, we need to give our group by condition, right? But before that, we also need to specify that the categories need to be laptop and the tablet category. And we also need to specify the stores and the year, right? So we will go ahead and give our where condition. So we need where our product dot So now our product name is either going to be laptop or it is going to be tablet, right? So our first condition is satisfied over here. So now our next condition is that our stores need to be located in Los Angeles, right? So I'm going to give my second condition is my st.city is equal to Los Angeles. Moving on to my third condition, the year is supposed to be 2023, right? So my sale date, so my s dot sale date is equal to, so my sale date needs to be 2023, but as you know, this is not the complete date format, right? I have my month and my day as well, but since I only need the year over here, so I'm going to use the year function over here to fetch the year from my sale date, and that year is supposed to be 2023. Alright. Now all these conditions have been implemented except for one, each product. So lastly, we are going to group by our p dot product name. Alright. So we have the total quantity, we have our each product, we have laptop and tablet, we have stores from Los Angeles, and we have the year 2023. So I think all the conditions have been implemented. Let's run our query. So the total quantity sold is 5 and we have laptop. But is this correct? So let's go ahead and check. So first let's look at all the sale dates containing the year 2023. It's 1, 2 and 3. Alright, so we are only going to look at these 3 particular rows. Alright, so now we need to find the city as well. So city over here is New York, so this is cancelled. So we are only going to look at these 2 particular rows. So as you can see, we have our output laptop and the quantity sold is 5. So basically we do not have any tablets being sold either from the stores in Los Angeles or the year 2023. Alright, we just have laptops and the total quantity sold is 5. So that is our answer. Moving on to our 7th question, we have our employees table over here. And in the employees table, we have employee ID, employee name and the manager ID. Alright, so now our question is, again, this is a very interesting question. So now you have to find the names of the employees along with the names of the direct managers. Now, this is a very interesting question, as you guys must have already realized. So now, basically, we have only one table. We have our employee ID, we have the name of the employee, and we have the manager ID. So basically, as you can see, the employee ID 1, Alice, is not having any manager. So maybe we can conclude that this particular employee is at the top position, or maybe he's the CEO of the company. So that is why he's not having any sort of manager above him. Then we have our second employee, Bob. He is reporting to Alice. Then we have Carol also reporting to Alice. So basically Bob and Carol have the same manager who is Alice, right? Then we have fifth employee, again having the same manager ID. So basically David and Emma both report to Bob, right? So similarly, we need to find the managers. Let's go back to our question. We need to find the names of the employees and the names of their managers. So now you guys must be wondering that we are not given any sort of manager name over here. But if you look at the table closely, we have the managers in the table itself. They are also employees over here, right? So that is why we have created 2 tables of employee over here. So basically we're going to perform a left join over here, and this is what our table is going to look like. So we are going to perform the joins on manager ID of our table 1 and employee ID of our table 2. So basically whenever we have our manager ID equal to the employee ID, we are going to join the tables on those particular points, right? So say for example over here I have my manager ID as 1 and over here I have my employee ID as 1. So basically over here, I'm going to have my employee name as Alice, right? Similarly, over here, I have my manager ID as 1 and my employee ID as 1. So I'm going to have my manager as Alice. Similarly, we're going to do that for the rest of the manager ID or the rest of the rows as well. And this is going to be a final table. And as you can see, we have the name of our employees and we have the name of our direct managers as well. So we just have to retrieve the data from this particular table in order to answer our question. So let's go ahead and implement the query. I hope the logic is clear. So if you guys understood the logic, do try and implement this particular query by yourself before looking at the solution, so that you guys have a better idea of how these kind of queries can be implemented, right? So let's go ahead and implement this particular query. So basically we're going to select our employee name. We'll call it e dot employee name. And we are going to select our manager name from our manager table. We'll call it m dot employee name again, because we do not really have a manager name column. Rather, we are going to fetch our manager names from our employee name column itself. Right? Now we're going to do this and we'll call this manager or manager name. We'll fetch this from our table employees, giving the alias e, and we're going to perform a left join on employees, giving the alias m on e dot manager id equal to m dot employee id. So that is it. This is all that we have to do. And as you can see, Bob reports to Alice, Carol also reports to Alice, then we have David and Emma reporting to Bob, and moving on we have Frank and Grace reporting to Carol. So this is the exact logic that we wanted to implement, and as you can see, Alice over here does not have a manager like we discussed. So that means our query is syntactically plus logically correct, right? So on that note, let's move on to our 8th question, where we have a table customers and a table orders. And we have a third table again called payments. So our customers table is going to have customer ID and the customer name. So we have 3 customers over here. Then we have our orders table maintaining all the orders, that is the order ID, the customer ID, the order date and the order amount. Then we have a third table which is payments, which contains the payment ID, the order ID, the payment amount and the payment date. Right, so once you have understood the 3 tables, now let's go ahead and look at the question that we have at hand. So we need to write a query to list the customer name, the total order amount and the total payment amount for orders placed in 2023. So now the basic approach I would follow after looking this question and looking at the tables or the data set that I'm given, I will simply go ahead and list out all the things that are mentioned in the question before implementing any sort of logic. Right, so I will go ahead and select customer name, total order amount means the sum of order amount, and total payment amount is again the sum of payment amount, right? For orders placed in 2023. Now, I do not know which table these 3 particular columns come from. So now I'm going to go ahead and look at that. So I have my customer name from customers, order amount from orders, and payment amount from payments. So I will go ahead and give the alias name for each of them, O dot order amount and P dot payment amount, right? Now, in order to understand the very first table I'm going to access my columns from, I need to find the common table between the 3 particular tables that are given to us, right? So we have our customers, orders and payments. So as you can see, I have my customer ID over here and customer ID over here. I have my order ID over here and order ID over here. So basically, orders table is our common table, which is connecting the three particular tables together, right? So basically I'm going to use my orders table to initiate the query from orders O, and I am going to join with, now I can join it with any table in any order. So since I have already accessed the common table in the very first go, I can now access any other table using this common table, right? So I will go ahead and join my customer C on C dot customer ID equal to O dot customer ID. Then I'm going to join my payments. Yeah. Now I'm going to join my payments table. Call it P. And I'm going to access on P dot payment ID equal to O dot payment ID. Right? So these are basically your foreign keys that are connecting the tables. Now that I have joined the tables, I have accessed these particular columns that we want to display in our query. Now is the time to give the conditions. Now we need to give the condition that our orders should be placed in 2023. So I will just give my where condition. So now our payment table and order table are actually going to be joined with order ID and not payment ID. Alright, so this was an error on my end. I'm sorry about that. So now we need to give a condition where the year of our O dot order date is equal to 2023. Right? Now we missed one condition over here, a very important one, which is each customer's name. So we forgot to implement the group by condition over here. We are going to group by C dot customer name. Alright, so let's run it. So we have an error. Okay, we misspelled customer somewhere over here. It's CUST customers. Alright, let's run it there. So basically we have the total order amount for Alice as 250, and this one has already paid the entire amount. Bob Johnson has also cleared his dues. So Charlie Davis has also cleared his dues. So as you can see, this is a very practical implementation of real world scenarios where a simple query can be used to find out all the customers who have their dues uncleared or are still left to pay, right? So this is how a simple SQL query can help you make really big analysis, right? Moving on to our 9th question, we have our books table and we have our borrowed table. So in our books table, we have our book ID, the title of the book and the author ID. Then in our borrow table, we have the borrow ID, the book ID and the borrow date. Alright, so the question here is basically write a query to find all the books that were not borrowed in the last 6 months. Again, this is a very practical and real world sort of question where we'll be using a really good logic and a really simple one per se and implement this. So first let's look at our tables here. So we have our books table and we have our borrow table, and we have our book ID common in the two tables. So we are going to join the tables, or you can say the borrowed table has a foreign key referencing to books, which is the book ID, right? So this is another way of saying this. So this is what our joined table, or after joining the two tables, this is what it's going to look like, right? We're going to have, so as you can see, book 1 was borrowed twice, as you can see over here. Book 2 was borrowed once, and 3, 4 were also borrowed once, whereas 5 was not borrowed at all, so that is why it is null. So according to this table, we should have Moby Dick as a book that was not borrowed in the last 6 months. Then The Great Gatsby was last borrowed in 2022. So this should also be counted. Then we have Pride and Prejudice, which was borrowed in 2023. So this should also be counted. Then we have To Kill a Mockingbird, which was borrowed in 2023 as well. So this should be counted. But again, we have To Kill a Mockingbird again, which was borrowed in 2024, and that is in the month November. So if we were to consider current date, it is 2024 11/8, and this book was borrowed just 3 days. So the previous entry should not be counted, you can say. So this book is not going to be included. Then we have 1984, which was again borrowed just a few months back in 2024. So this is again not going to be included. Right, so now that you have understood the logic behind the query, let's go ahead and implement it. So we're going to have to display all the book titles. So we'll call it b dot title from books B, right? And then we are going to perform a left join, because we want all the books, even the books that are not there in the borrow table, we want to include those books as well, right? So we are going to perform a left join so that all the books from our books table are included in our join table. So we're going to perform a left join on borrowed. We'll give an alias name BR. Alright. We're going to perform the join on B dot book ID equal to BR dot book ID. Alright. So now our condition is books that were not borrowed in the last 6 months. So now we need to give our where condition, where my book ID should not be in the subquery that I write now. So I am going to select all the book IDs from borrowed and give a condition that my borrow date should be greater than my current date minus the 6 months. Alright, so this is my condition over here. Current date is basically the current date. So minus interval 6 months is basically specifying that I want to subtract 6 months from my current date, right? So I have given the condition that my borrow date should be greater than the 6 months back from today, right? So if the current date or the current month is November, my borrow date should have the month greater than June, right? So if the borrow date, that is basically the books were borrowed after June, that means they were borrowed in the 6 months period from today, right? So they cannot be included in the not borrowed in the last 6 months category, right? So that is why I am specifying a condition not in, and I am selecting all the books that were borrowed in the last 6 months, right? So this will help me find all the books that were not there in the last 6 months. And then I'm simply going to give my other condition, or my second condition is going to be where my borrow date is null, right? So books that have never been borrowed will also be included in my query result. So br dot borrow date is null. Alright, so let's run it. Okay, so there is a spelling error over here. It is C-U-R-D-A-T, not C-U-R-R. So as you can see, we have Pride and Prejudice, The Great Gatsby and Moby Dick like we discussed, right? These 3 books have been included in our query result. So these kind of questions where you have to subtract the date, you have to use this kind of syntax. Or another function you can use to subtract the date is add date, right? So you can either use add date or you can use the current date minus the interval of whatever interval you want to minus. It could be 6 months, it could be 1 year, or it could be 6 days as well. Right? Moving on to our 10th question, which has the table departments, employees, and salaries. Right? So in our departments table, we have our department ID and the department name. In our employees table, we have employee ID, employee name, and the department ID. Right? And then in salaries table, we have our employee ID, salary, and the effective date. Right? So as you can see, our employees table is the common table connecting our department table and our salaries table. Right? So now our question is to find the total salary expense for each table for the latest salary records only. Right? So for each department, there are salary records. Now for the latest means the maximum date, right? Out of all the salary records, out of all the dates, we need to find only the maximum one or the latest one, and we need to find the total salary expense for each department regarding that particular date itself, right? So our query is going to be something like this. We need to find the total salary expense for each department. So let us also print or also include our department name in the query, and we will have our sum of our salary, right, as total expense we'll get this from our salaries table. We'll call it S. We'll perform a join on employees E on S dot employee ID equal to E dot employee ID. Then we'll perform the other join on departments, call it D on E dot department ID equal to D dot department ID. Alright, so the joins are clear. Now we need to find the total salary expense, which is over here. For each department, we also need to give a group by condition for each department, right? So let's look at the department table over here. So we'll group by department ID itself. Department ID. Alright. Now before this, we also need to give a where condition, where we need to find the total salary expense for the latest records only. Latest salary records. Latest salary records is, say, for these two particular entries over here for department 101. I have the entry of 2023 and 2024. So over here in this case, I'm only going to consider this particular entry, which is the latest salary record. Right? So this is what the question is trying to say over here. So for this particular logic, we're simply going to give the condition where our S dot effective date is equal to, we're going to perform a subquery over here. We're going to select our maximum effective date from our salaries table, and we are going to give a condition where employee ID is equal to E dot employee ID. So now in order to understand this particular subquery that we have performed over here, we are going to look at the table in just a few more minutes. But before that, let's run our query. I'm sorry, the name of my table is employees underscore. Alright. So let's run it again here. So we have our human resources having 62,000 as we discussed over here. This being our latest salary record, right? So as we discussed, this is the logic that's been implemented. Now before moving on to the next question, let's quickly look at what was happening behind the scenes when we join these two tables given based on the conditions, right? So we have our effective dates bifurcated over here. So now as you can see, for each department, we have a particular salary associated. So now our effective date over here is basically our latest salary record, right? So we have joined the table based on this condition. So now in order to get a better understanding, let's match our query result with our table over here that we get after performing all the joins and implementing all our conditions, right? So as you can see over here, for department name human resource, I have my salary as 62,000 and this is my latest salary records over here. Right, so after giving the conditions, my effective date over here is my latest salary records. For engineering, it is supposed to be 80,000. For marketing, it is supposed to be 55,000. And for finance, it is supposed to be 70,000. So now let's look at our records. We have 62,000, 15,500, 55,000 and 70,000. So apart from engineering, we have all the records matching over here. So let's go ahead and look at our query. So you can see engineering has the department ID 2 and this department ID 2 is being accessed by 102 and 104 employee IDs, right? So employee ID 102 and 104, as you can see over here, this and this, right? So these both are going to contribute to the engineering department. So that is why the sum of 75,000 and 80,000 has been displayed over here as 1550, right? So now I hope that was clear. Now let's move on to our 11th question. And for that, I have created a separate database, as you can see over here. We have our two tables for 11th question, which is products and orders. So products table is going to have product ID, product name and the price. And then the orders table is going to have order ID, product ID and the quantity. Right, so our 11th question basically wants us to find the names of all the products that have been ordered more than 5 times across all the orders, right? So now we have our orders table over here, which is keeping track of all the orders that are being placed by the customers. So what we need to do over here is, we need to find the names of all the products that have been ordered more than 5 times across all the orders. Right, so now this question can be performed in two ways. It can either be performed using joins, which we have been doing till now, or it can also be done using subqueries. Right, so here we do not need to join the two tables and then find our particular answer. Rather, we can directly perform subqueries and apply all the conditions that are mentioned in the question. So I will show you the query approach. You can go ahead and implement the join condition yourself. So for the subquery method, we're going to use our product name from products table, where my product ID is in. Now here comes my subquery clause. So now I need to find the product name of all the products that have been ordered more than 5 times, right? So I need to find all my product IDs. Since product ID is a common column in both the tables, I can simply access my product IDs that have been mentioned more than 5 times over here. Sorry, the quantity needs to be more than 5, right, of all my products. So what I'm going to do is I'm going to count the quantity, that is I'm going to find the total quantity of all my products, and then I am going to return all the product IDs that have the quantity more than 5, right? So in order to do that, we're simply going to use our select statement, and we need our product ID from orders. Now over here we need to group by our product IDs using product ID. So now our condition is that the sum for all the quantities should be greater than 5, right? So this particular query should give me the desired answer. Let's run it. And here we have smartphone, tablet and headphones. So let's go ahead and cross check this. So I have my product ID 1 being ordered just once, right? So it is 2. My product ID 1 is laptop. So as you can see, laptop is ordered only twice and hence its total quantity is less than 5. It is not included in our result. Then I have my product ID 2, which is ordered 20 and 3 times. So it is ordered 23 times. My product ID is 2, smartphone, which is included, right? So you can cross check your answer like that, and you can be 100% sure whether the logic you have written or whether the syntax you have implemented is correct or not, right? So in our case, it looks correct. You can cross check further and comment below if there is any error, right? Moving on to our 12th question, we have our table employee. And in our employee table, we have our employee ID, employee name, and department ID and salary. So now what we need to do is we need to find the names of the employees who earn more than the average salary of their respective department. Now over here, first we need to find the average salary of each department, and then we need to find the names of the employees who earn more than the entire average of that particular department that they belong, right? So this particular query can be implemented in a very easy manner. Employee's name. So we are finding all our employees' name from our table employees. We'll call it E1. Alright. And then we're going to use our subquery and we're going to give a condition where our salary is greater than, and we'll implement a subquery over here. We'll select average salary from our employees table itself. We'll call this employees table as E2. Alright. Now the condition is either we can use group by, right? We can use the group by clause, or we can use this clause E2 dot department ID is equal to E1 dot department ID. So basically it acts like a group by clause, but instead of implementing it twice over and over, we just do it with this simple line. So this is basically going to find the average of the salaries department wise, and this is the condition that helps it do so, right? So if we implement it, it's employee name, right? Let's also print the salary. Okay, so let's also print the salary to get a better idea. Okay, right. Oh, what if I wanted to print the average salary over here? So I also will have to implement the group by clause. So I will have to group by my department ID, right? So these are the average salaries for these particular employees, right? So this is the other way of implementing it, but this is our solution over here, right? This is going to be our answer. David Brown, Emma Stone and Rob Davidson. Alright, so this was all about our 12th question. So now let's move on to our 13th question, which contains the table sales. Now this sales table has a salesperson ID, it has a sale amount and a sale date, right? Now what we need to do is we need to write a query to find out the rank of each salesperson's sales for each product based on the amount, with the highest sale ranked as 1. Now what this question is basically saying is, so now we have the salesperson 1 and we have 2 entries. Okay, for now let's just consider these 3 rows, and we have 2 entries for salesperson ID 1, right? Now what the question is saying is that we need to rank the sale amount based on the highest sale. Now over here, the highest sale over here is 5,000. So this is going to have rank 1, and then 4500 is going to have rank 2, right? So this is a very good implementation or a very good example of using the rank function. So let's go ahead and implement it. So let's display the sales person ID and let's display the sale amount so that it is easier for us to cross check. And then let's implement our rank function, right? So now rank has a mandatory syntax where you need to use rank, or it could be row number or any sort of syntax like that. Wherever we use the window functions or the ranking functions, we need to use the over clause along with that. Like we need to have the over followed by the previous function. By our sales person ID, and we are going to order, basically sort, like we're going to rearrange in descending order. This is also supposed to be capital. So it needs to be ranked by the sale amount in descending order, right? We'll give an alias as sale rank, and we're fetching all this data from our sales table. But as you can see over here, I'm getting an error. So this is mainly happening because my SQL is an older version and it does not basically support the rank function. So what I'm going to do is I'm going to run my entire query on an online compiler. Okay. Here, so as you can see, this is my result. I have all the salesperson ID 1 and I have given the rank 1, 2, 3, 4 based on their sale amount, right? 5,500 gets 1 because this is the highest. Then we have 5,000, then 4,500. So this is basically arranged in a descending order, right? So this was all about question 13. Okay, so this is also how you can check your SQL version minus 5.5. So basically rank functions are usually supported in SQL 8 and above. So if you are using an SQL version 8, you will easily be able to perform the rank functions and all the new window functions that are available. But if you're using an older version, you will have to use an online compiler or maybe update your SQL version. Alright, so moving on to question 14, we have a table daily sales. Alright, so now in our daily sales, we have a sale date and we have our amount. So now our question here is that we need to calculate a 7-day moving average of daily sales amounts. Now say instead of 7, we had a 3-day moving average. Alright, so first we would calculate the average of these 3 particular rows. Then we would go ahead and move to these 3 rows, and then we would go and calculate the average of these 3 rows and so on. So this is basically a window function, or you can say a moving average, right? So in order to implement this particular query, we'll be using our select statement. So we have our sale date and our amount. So we'll display that using star. Then we'll go ahead and display the average of our amount over. Now this is our window function over here. We'll be calculating our average over order by sale date. Now since we need a 7-day moving average, we are going to calculate our 6 preceding rows, right? So row 6 preceding means we are going to start from the 7th row, right? So this is 1, 2, 3, 4, 5, 6, 7. So this is where we're going to start, and we are going to calculate, we are going to consider the 6 rows preceding our current row. Then we are going to go ahead and move to the next row and consider the 6 rows preceding it, right? So this is what it basically means. But as you can see over here, we have an error again. So we are going to have to implement this also on our online compiler. But let's complete our query. Let's give it an alias name. We'll call it moving average from our daily sales. I will just copy and paste this on my online compiler so that you guys are able to see the result. Okay, I'm sorry, it is rows. Right, so this is your moving average. You have the average for all these rows. You can also go ahead and cross-check the answers. Then lastly, we have our 15th question. That is the last question for this particular video. So you can see this is a somewhat different question than what we have been doing till now. So basically, we have to write a query to classify each student based on their score. Alright, so now the three categories are high if the score is 80 or above, medium if the score is between 50 and 79, and low if the score is below 50. Alright, so these are the three categories, and we have a table student where there is a student ID, there's a name, and there is a score. Alright, so I have already written the query for you guys over here. So basically, we're going to implement the case statement. So whenever we're using the case statement, the most important thing to keep in mind is the syntax, right? If we have the right syntax, the logic is pretty much, in general, very easy to implement, right? So we are already given the condition. We just have to implement the case statement and we have to specify all our conditions over here. It's like using if-else. Alright, only the syntax is different because it's SQL. So where our score is more than 80, we are calling it high. When a score between 50 and 79, then medium, else low. End as score category. Now, as score category is our alias, and we are extracting all this data from students. So let's run it. And you can see we have a neat table indicating the categories of each student based on their scores. Alright, so this was it for this video. I hope you guys enjoyed it and also understood the major concepts that we intended to deliver through this video. If you guys liked it, do hit the thumbs up button and subscribe to our YouTube channel. Thank you and see you in the next video.